This hopefully is already in your spiral. Okay. After the orange foldable, this is orange, we are going to put in this practice we just did, rules of exponents. Okay. And then after the rules of exponents, and if you want to complete it first, that's fine. We're going to do the mixed practice next. So get the mixed practice that I just passed them out to each group. We're going to go through these together. And we'll talk about which ones are kind of like star questions, how they show your multiple choice answers to get to the right solution. All right. Okay, let's talk about this. I want you to see if you can recognize which rule to use. So you can have the orange out if you need it to help you. Some students kept this one out because it had each rule on it, if you want to refer to those as well. But you have to look at the given problem and identify which rule to use based on what you see, okay? So like on number 1, because I see these parentheses right here, and I have the exponent outside the parentheses, we should be using the power rule. What does the power rule tell us to do? Yeah, you multiply the exponent. So this gets simplified as x to the 10th power. Because we did x and had a power 2, and then we multiplied it to that 5. So x to the 10th is the final answer. Okay, so number 2 is the same rule. Because hopefully you see again you have parentheses and you have an exponent outside that parentheses. So you some people think of it as like distributing. If you want, you can think of it as you're using that exponent to each letter. Okay, so the first letter we have is the M. It has an exponent of 7. Then I'm going to multiply it times that 4. Then I go to the next letter, which is the N. It had an exponent of 4. And then I'm going to multiply it times the 4. So it's like distributing the exponent to each variable. Okay, so you're using the power rule on each letter. Okay, see if you get that final answer. Okay. So when you write this, this should be M to the 28th power and N to the 16th power. If you're not sure about the multiplication, just use the calculator, guys. You're going to need it today. Trust me. Just get a habit of using it. All right, number 3. Okay. Again, hopefully you recognize, you see the parentheses. Sorry. All right. And we have the exponent outside the parentheses. So again, this is power rule. What do you think the answer is? Close. You're close. Okay. Because you have the 5, right? That's your coefficient. You're going to have to distribute this exponent to that 5. So that's going to be 5 squared. You see what I did? I put the 2 with the coefficient, with the number. Then I go to the variable, which is x. X has an exponent of 7, but now I multiply that times 2. Okay, so this gets simplified to what? 25, yeah, it should be 25 is your now new coefficient. Because 5 squared, and if you weren't too sure, you just put 5. Let me clear this out so I can start over. And clear. All right. So 5 squared is 25. So we were going to write the simplified answer would be 25x to the 14th. Because you're doing 7 times 2. So you might need to remember right here, this is just a little note, that examples with coefficients, remember that's your number in front. That was that 5. Number in front of variable. If you have a coefficient, okay, you have to take that coefficient and raise the coefficient to the given power. Okay, simplify the variables with the power rule. Everything else is the power rule like we've used before. So, do we have a coefficient on number 4? Do you have a coefficient on number 4? Do you have a number in front of the variable? I'm talking about letters, guys.
Yes.
What is that number?
2.
2 is the coefficient. We have parentheses, and we have the 5 outside the parentheses. So we take that 2, and we raise it to the power of 5. Then we do each variable with the power rule. The x squared, we do times 5. And the y, which is the next variable, it doesn't have an exponent, so we raise it to that power. So the y has now a power of 5. So now we simplify this. What's 2 to the 5th power? Yeah. So this comes out to be 32 x to the 10th power, y to the 5th power. All right, I need you to try number 5. If you want to do one at a time, like I'm trying to model, you can.
Well, you put a parenthesis in 4, right?
Yes. All right, do we have questions? Because it's actually a positive 256, not a negative 256. It's a positive 256, not a negative 256. You have to put this negative 4 in parentheses. And then you got to understand that if you're raising a negative 4, if you're putting a negative 4 to the 4th power, that is saying a negative 4 times a negative 4 times a negative 4 times a negative 4, 4 times.
Yeah, that would cancel out.
Okay, let me move this over. So, because I'm doing it 4 times, right? Think about it like this. What happens when you do a negative times a negative? It becomes a positive. So right here, I don't mean to change that to that. Sorry. So this right here, when I do that, that becomes a positive 16. Then I'm multiplying it by a negative 4 and times a negative 4. So then when I do a positive 16 times a negative 4, that gives negative 64. Then I'm multiplying it by another negative 4. So because I have a negative times a negative, that becomes a positive 256. So what you have to remember, let's say you make a computation or typing error. You have to remember if it's even, if your exponent is even, okay, then it's going to always be positive, a positive answer. If the exponent is odd and you have a negative number, okay, if you have an odd exponent with a negative number, then it was going to be negative. If it's even exponent with an integer with a negative number, it's going to turn into a positive answer. Even exponents are always positive. All right, so let's do some mixed practice. On number, why is it doing that? 6. What should we do first?
distribute.
Yeah, the parentheses right here distribute this 3. I'm trying to give y'all time to try it first, so we're doing the power rule first. You need to rewrite what's in the parentheses. Distribute the 3. That means we're going to multiply the exponents. So what does this become? X to the what? Come on, guys. X to the 9th. And Y what? To the 9th. Then I'm going to multiply that to what I have, which is x, y squared. Now, because you're doing multiplication right here, this is the product rule. Yeah, so we're going to add the exponents. If I add the exponents for my x's, what am I going to have a total of? Yep, x to the 10th power. Yep, and then if I add my y's, that's going to be to the 11th power. And that's the final answer. So on number 7, where do we start? Anyone? Okay, I'll let you write it. Yeah. When you start with the parentheses, you don't have a parentheses anymore when you distribute the 4. I don't know if y'all noticed, but like when I started with the parentheses here, when I wrote it, there was no more parentheses because basically I used the rule to get rid of the parentheses. All right. Hopefully we have a negative a to the 8th, b to the 4th. I'm distributing the 4 to each variable, the exponent. And I'm now just going to take that and multiply it to a to the 3rd power. Okay, so what does this now become? Because what are we going to do now? Yeah, which exponents can you add? Yeah, the a's. Because it's a product, you're multiplying, you can add those. So what's our final answer? It'll be negative a to the what? To 11th power and b to the 4th. Yes.
Why didn't you put a parenthesis in A the first time?
Oh, because I know that if it's even, like I know when I multiply it, when I distribute it, because I knew I had another thing to do. I just knew that it was going to be the negatives in front of the a. It's not part of the whole. Yeah. Yeah, it's like a 1 in front of it.
So if it's a number, you would put parentheses around it, but if it's a variable, you wouldn't.
Yeah, it would be like a 1. Well, actually, because we distribute the 8, I'm sorry, you're right. This 8 is an odd number, so this would end up being positive.
That's what I was confused.
Yeah. Like you could, yeah, I think of negatives like negative 1s and being in front. Like I think of it as a coefficient of a negative 1.
Okay.
Yeah.
So would there be a question where the A would be negative?
If the exponent was odd, it would stay negative. Like if the,
7.
yeah, so if it was like a 7, then yes. Yeah, like if, yeah. So when you did it, if you started off with an odd number, then it would stay negative. Yes. All right, so on 8, we got 2 sets of parentheses. So I'm just going to do the first set first, basically. Just do the power roll to each term. This 2 on the outside is going to go to each part. So even if I wrote -2 squared and a squared, and now b is not squared anymore because what do I do to the exponents? You multiply, so that's b to the 4th. And then I see that this -2 right here has an exponent of 2, right? And 2 is even. So what does that number turn into? +4. So our final answer would be 4a squared b to the 4th on this part, just for this set of parentheses. I'm trying to give y'all time, guys. Like, I'm trying to let you try to write it and then check. But y'all have me worried. I didn't think I was going to have to worry about y'all, but y'all are way too quiet today.
9a to the power of 4. The second power.
Yeah, this one we're going to do the next set of parentheses, which has a 2. I'm distributing that 2 to each term. So yes, this becomes 9, a to the 4th, b to the 2nd power. Now, because we're multiplying, what do we have to do to the exponents? You would add them. You add the exponents, but you go ahead and multiply the coefficients. So you are doing 4 times 9, which is 36. I'm going to do it underneath. And then this would be a to the 6th power, b to the 6th power. So do a parentheses. Parentheses is first, just like in order of operations. Parentheses comes before anything. Comes before exponents, comes for multiplying. So we need to do this set of parentheses first. If you do the power rule to that binomial, let's see if you can get the correct results. Okay, you get your exponents right, but you didn't do it to the 3. You have to put this 4 to this 3 to the power of 4. That's why I'm trying to write it with that exponent. What's 3 to the 4th power? 81. That some of you are multiplying 3 times 4 and doing 12. No, you have to raise it to that power, guys. Like, I'm not expecting you to know that. So just put your exponent box. You're not multiplying the number, the coefficient. You're only multiplying the exponents. So this should be 81 x to the 12th power y to the 4th. Then we had a minus, and we're going to do the next set of parentheses. So try the next one. Again, you have to fix the number. You're not putting that to the power of 2. Yeah, that's right. Kayla, I know you work ahead, that's fine, but you need to check because your steps are off. Like, I was looking at your work. I need you to fix a couple problems.
Yeah, I'm doing it.
All right, what's the next one here? What does this turn into?
49,
Yeah, 49.
25th power.
No. To the 10th power.
Y to the 2.
Yeah, y to the second power, or y squared, yes.
Then move down x to the second power and y to the second.
Yeah, we bring that down, x to the second, y to the second, and we're multiplying those. And because we're multiplying these two here, we use the product rule. Yep, we do addition. So do the addition to only the last two terms. What's your final answer? Check your exponents though. I think they're inverted. Uh-huh.
For,
You subtract.
oh.
Sorry. All right, sorry. All right, so this one right here is still a coefficient of 49. But now it's x to the 12th, y to the 4th. You should have added those exponents. And we had the 81 x to the 12th, sorry, 81 x to the 12th, y to the 4th. Okay, so, and we're subtracting them. Because the variable and the exponents are the same, that means you have like terms. So now we're just subtracting the coefficient. You don't change the variable and exponent. You keep it the same, and you just subtract the coefficient. So 81 minus 49, it's going to leave you with 32. And then you keep that variable the same. So x to the 12th, y to the 4th. Yes. So we're going to take these same rules, these same mixed kind of approaches, and now apply it to geometric figures. So if you go to the next part.
This is algebra.
Okay, so first, just to recap, everyone understand what perimeter means?
You add all the sides.
Add up all the sides. That's basically what you're doing for perimeter. Don't worry about the figure, just add up all the sides. So if I'm going to do the perimeter of this figure, which is a rectangle, I would say P is for perimeter would equal my 12x plus my 5x squared, and then I would have another 12x because this would be over here 12x, and this would be 5x squared. I got to go all the way around. So 12x plus 5x squared. Now, when I'm adding, I can only add the like terms. So which are like terms?
12x.
Yeah, 12x and 12x, so that gives me now a total 24x's. And then the other set of like terms,
10x to the.
yeah, 5x squared and 5x squared, so that's 10x to the second power. And that is our expression for the perimeter. That's our answer for this one. There is no solving. Yeah, you can't. Well, yeah, we have to have numbers. We have to have an equal sign. So you can't really solve it. They're not like terms. I mean, we would need some actual values to do another step. All they want you to do really is to write an expression to represent the perimeter. Okay? Now, for area, I guess you have to kind of remember how to do the area of a rectangle. And that's just saying length times width. Okay? So what could we say is the length of this rectangle? Yeah, so I'm just going to put in parentheses 12x for my L, and I'm going to multiply that to the width, which is 5x squared. Because we're multiplying, Okay, what's the rule?
You add the exponent.
Add the exponents. We're still going to multiply, yeah, the number 12 times 5. So this comes out to be 60 to the power of 3. Yeah, 60x cubed or x to the third power. So this is that final answer. All right, so if I'm doing perimeter of this triangle, adding up all the sides, we got 4a squared b plus 10a squared b plus 3ab. We're adding up all the sides, and we're only combining the like terms. Which ones are the like terms? Yeah, 4a squared b and 10a squared b. So that means I have 14a squared b. Don't add the exponents. You just keep the letter and the exponent the same, plus the 3ab. All right. Now, for area with dealing with the triangle, you have to remember area is base times height divided by 2. All right, so your base and your height are where basically you have the right angle. So this would be the base, and this would over here would be your height. So we're going to substitute those parts in for the formula. So this would be, why does it keep on sliding down? 3ab for b, parentheses times our 4a squared b, and then divided by 2. Sorry. You have to do the multiplication first. So when I simplify the top, it becomes 12a to the third power b squared. Questions on that step? You multiply the numbers, you add the exponents. Now that is written over 2. And then this can be simplified. What do we get here? Because you can simplify 12 divided by 2. That we can reduce. So your final answer is 6a cubed b squared. A cubed and b squared. All right, on 12, it's missing. It's not stated, but we just need to add this to help you see it better. This triangle, is an equilateral triangle. So all sides are congruent or equal. All right. So every single side here is going to be 20 m cubed into the fifth. Okay. I know that's kind of off. Let me move this, center this a little bit. There we go there. Which means this side over here is also 20 m cubed into the fifth. All right, so if they're all the same measure, the same expression, then the perimeter, I would just have to say 3 times that 20 m cubed into the fifth. And since I multiply by 3, this is really just going to come into be 60 m cubed into the fifth. That's our perimeter. Your area for the triangle is still going to be the same. You're going to do the base times the height divided by 2. You're still going to have to do base times the height divided by 2. We just want to make sure you recognize that this little dotted line here, they're trying to make sure you understand that that is the height of the triangle. Height is always perpendicular, meaning you should see a box like we have right here. So if I substitute the parts into the formula, sorry, what would I use for the B, or the base of the triangle? Yep. You use the 20 m cubed into the fifth. That goes in for B. And then what represents the height of the triangle? Yeah, 4m n to the fifth power. So those two are going to get multiplied together first, and then we're going to divide it by 2. So what do we have? What's the product on the top? What do we write on the top? 80. What? Yep, to the fourth and to the 10th. So what does this get reduced to? Yep, 40. You keep the variable and the exponent. So this final answer is 40 m to the fourth power n to the 10th. All right, so the last page. Now we're going to do mixed practice with quotient rule division. So when we are dividing exponents with the same base, like on 13, what would this answer be? Yeah. Yeah, k to the 10th power. You just subtract the exponents. All right, so on 14, just because you got more variables doesn't mean you change the rule. You just do one at a time, okay? So if I look at my p, all right, what does this p get simplified to? Yeah, p to the third power, p cubed. All right, then I go to my q to the 16th divided by q12, or 16 minus 12 gives me q to the fourth power, and that is our final answer. All right, so for 15, now we have coefficients. So you're still gonna divide your coefficients. If I have a negative 36c squared d to the fifth, then, oh, I didn't mean to do that. Okay, so then, what does this turn to?
Negative 9.
Yeah, negative 9d. You can do the number, the 36 divided by 4, that's the negative 9. Then you do your c squares. If I have c to the second divided by c to the second, what is that? Huh?
You have no C.
You have what?
You have no C.
Yeah, there's no c. They're canceled out. Then go to your d's. D to the fifth divided by d to the third, d to the second, and this is the final answer. So if you have coefficients, just remember to divide the coefficients and then simplify everything else, the letters, the variables, using your quotient rule. All right, so let's simplify 16. Negative 15 divided by negative 3.
5.
Positive 5. All right, then we go to the letters. We got an x.
X to the first power or just X.
Yep, x to the first power or just x. Then we go to the y's.
Y to the second power.
Y to the second power. And I just now saw that. We have also a z,
Which is just
and it's just a z. So this is our final answer. Now, if you have coefficients Like here we have 36 and 45 and 54. That can be reduced.
Those 2/3.
Yep, so 2/3. And then you look at your variables. M to the 6th power, n to the 3rd. All right, so on the mix practice here, oh, dang it. You're going to need to do your parentheses first.
Wait,
What?
parentheses over here.
Mhm. All right, so when you distribute the 3 exponent to every term, the top now becomes 8, a to the 6th power, b to the 12th power. That's going to be over 4, a to the 3rd, b to the 7th. All right, so we can reduce the 8 over 4. So that becomes 2. Then if you look at the variable a to the 6th divided by a to the 3rd, 6 minus 3 gives me a to the 3rd again, a power of 3. And then you go to your b's. 12 minus 7 leaves you with 5. So it's 2a cubed b5, b to the 5th. Okay. Now 19, you have to do the parentheses first on the bottom. So everything on the top stays. So 12w to the 9th, v to the 4th. But this now becomes 16 w squared, v squared. All right, you can reduce this part of the fraction. What is 12 over 16 reduced to? Yep, 3/4. So then we're just subtracting. This would be w to the 7th power and v squared, v to the 2nd. Is that all of them? Yeah. All right.